Ever tried buying, like, concert tickets and the website just crashes? Super frustrating. Well, that's where load balancers come in. They're kind of like the unsung heroes that keep websites and apps running smoothly, especially when tons of people are trying to use them at the same time.
Right.
So today we're going deep dive into how these things actually work, and we're going to be looking at load balancing algorithms.
Hmm.
We're going to try to break down these key algorithms, these strategies that these digital traffic cops use to keep everything flowing.
Yeah, it's interesting because they use different strategies depending on, the needs of the system at that time.
Okay, so it's not like one size fits all.
Not at all, no.
So it's kind of like having different plays in a football playbook,
Yeah.
right? You choose the right one based on who you're playing against.
Yeah, exactly. And, one of the simplest but still very effective algorithms is called round robin.
Round robin. Okay,
Yeah.
so that sounds pretty straightforward.
It is. Think of it like dealing cards.
Okay.
So each incoming request is assigned to the next server in order. So it goes, around and around.
So if there are 3 servers, the first request goes to server 1, second to server 2, third to server 3, and then back to server 1.
Yeah, exactly. You got it. And it works really well when all the servers have similar processing power and you're expecting, a fairly even spread of traffic.
Okay. But what if one server starts to get overloaded?
Yeah.
Like during, I don't know, a flash sale or something. Would round robin make things worse?
It could. It could, because if one server is slower or starts to struggle, then, it can create a bottleneck. And that's where a more sophisticated algorithm, like least connections, might come in.
Okay. Least connections. What's the logic behind that one?
So this is all about efficiency. It's constantly checking which server has the fewest active connections at that moment and sending the next request to that server. So it's kind of like, if you're at the grocery store and there's a bunch of checkout lines,
Yeah.
you naturally pick the shortest one, right?
Right.
So least connections is trying to balance the workload by sending requests to the servers that are less busy.
Okay, that makes sense. So we've got round robin for simple fairness. We've got least connections for better resource management.
Right.
But what about when speed is super crucial?
Yeah.
Like for online gaming, I'm guessing there's an algorithm for that too, right?
There is, and that's where least response time takes center stage.
Oh, okay. Tell me more about least response time.
So imagine you're trying to buy tickets for a concert, and every millisecond counts.
Right.
Least response time is constantly monitoring which server is responding the quickest and then sending your request to that server.
So it's all about minimizing lag.
Exactly. It's
Yeah.
trying to ensure the fastest possible experience for the user.
That's really cool.
Yeah.
But how does the algorithm actually measure response time in real time?
So it's constantly pinging the servers and tracking how long it takes them to respond. And then it uses that data to make decisions about where to send the next request.
Okay, so it's very dynamic, very adaptive.
Very much so.
Okay. So we've got algorithms focused on fairness, resource management, and speed.
Uh-huh.
What other tricks do load balancers have up their sleeves?
Well, there's one called IP hash, and it's all about maintaining consistency for an individual user.
Okay.
So it takes the user's IP address, runs it through what's called a hash function, and then it uses that result to always direct that user to the same server.
So if I'm constantly browsing a website, IP hash will basically give me a dedicated server for my entire session.
Yeah, pretty much. And it's particularly useful for applications where session persistence is important.
Okay.
So think of things like online shopping carts or personalized user dashboards.
Makes sense. You want to keep that data together.
Exactly. So no matter where you go on the site, your information stays on that specific server.
Wow. I never realized how much thought goes into making sure our online experience is smooth. It's incredible.
There's a lot happening behind the scenes.
So IP hash is all about keeping things sticky.
Right.
What about situations where you have servers that have different capabilities?
Yeah.
Some are more powerful than others. Can load balancers handle that kind of diversity?
Absolutely. And that's where weighted algorithms shine. So imagine a golf game where, some players get a handicap based on their skill level.
Right.
Weighted algorithms do the same thing for servers. They assign weights to different servers based on their, processing power, memory capacity, other performance factors.
So a really powerful server would get a higher weight and therefore more requests.
Exactly. It's a way to account for the diverse capabilities within a server pool.
Okay. So it's like putting your strongest players in the most important positions.
Yeah, precisely.
Makes perfect sense. Now, what about location? Does that play a role in load balancing?
It does, and that's where geographical algorithms come in.
Geographical algorithms. Okay, I'm intrigued. Tell me more.
So, if you're accessing a website from London, it would make sense to connect you to a server that's in Europe rather than one in the US, right?
Yeah, for speed. Right, to reduce that latency.
Exactly. So these algorithms try to route your request to a server that's physically closer to you. And this is especially important for things like online gaming or video conferencing, where any delay is noticeable.
Yeah, that makes a lot of sense. This is all starting to feel like a huge, complex puzzle, but I'm starting to see the big picture.
There's a lot going on, but it all works together.
Yeah. Okay. So last algorithm, bring it on. What's the final piece of the puzzle here?
So this one's called consistent hashing. And this one is a little bit more complex, but it's incredibly powerful for, large-scale distributed systems. So imagine a circular ring called a hash ring.
Okay.
And both the servers and the data are assigned positions on this ring based on their hash values.
So I'm picturing a clock face where, like, each number represents a server.
Yeah, that's a great analogy. When a request comes in, the load balancer basically hashes that request and finds its position on the ring. And then it just sends that request to the first server that's located clockwise from that position.
So it's kind of like assigned seating in a circular theater.
Exactly. What makes consistent hashing really clever is that it handles server changes really well.
Okay.
So if a server goes down or a new one is added, you only need to redistribute a small portion of the data.
Okay. So it minimizes disruptions.
Yeah.
Yeah.
It ensures the system remains really stable even when things are changing.
That's amazing. So it's built for scalability and resilience.
Absolutely.
Okay. So we've covered like a whole bunch of different algorithms here.
We have.
I feel like I'm starting to see the bigger picture.
Yeah.
But I got to ask, what happens if the load balancer itself goes down?
Yeah.
Isn't that a single point of failure?
It is. If the load balancer fails, the whole system can come crashing down. That's why you need to have strategies in place to prevent that.
So what are some ways to protect against load balancer failures?
Well, redundancy is key. It's like having a spare tire in your car.
Right.
You want to have a backup load balancer ready to go if the primary one fails.
Okay. So if one goes down, the other one seamlessly takes over.
Exactly. It's like having an understudy for an actor in a play. But it's not just about backups. You also need to be monitoring those load balancers.
So it's like having a doctor on call, right? Constantly checking the vital signs.
Exactly. And a lot of modern systems employ what's called auto-scaling and self-healing mechanisms. So they can automatically detect a failing load balancer and spin up a new one.
Whoa, that sounds really advanced.
And then you have something called DNS failover, which basically redirects traffic away from the IP address of a failed load balancer to a standby IP address. It's like having an alternate route on your GPS.
Okay, so it's like a backup route in case the main one is blocked.
Exactly. It's all about minimizing downtime and making sure those applications stay accessible.
Okay, we talked about the algorithms.
Yep.
And we've talked about preventing load balancer failures.
Right.
I'm curious about the different types of load balancers themselves.
Yeah.
I know there are hardware options, there are software options.
Mm-hmm.
Can you give us a little overview?
Sure. So hardware load balancers, those are dedicated physical devices, often used by large organizations for their power and their security. So think of like the huge server racks you see in data centers.
Got it.
Well-known examples would be things like F5, BAE IP, Citrix ADC. They're known for their really high performance capabilities.
Okay, so the big guns. And then on the other side, we have software load balancers.
Right. Those run on standard servers. Generally, they're more cost-effective. Some popular options there are things like aproxy and NGINX.
And I assume the cloud providers have their own solutions as well.
Of course they do. Cloud-based load balancers are super popular as more and more businesses move their operations to the cloud.
Right.
So you've got AWS Elastic Load Balancing, Azure Load Balancer, Google Cloud Load Balancing.
So it sounds like there's a load balancer for every need and budget.
There really is.
But with so many choices, how do you know which one to choose?
Well, it really depends on your specific needs. The size and complexity of your application, your budget, your technical expertise. There's no easy answer.
Okay, so it really is about finding the right tool for the right job.
Exactly.
This has been incredibly informative. We've covered a lot of ground here.
We have.
I'm already feeling a lot more knowledgeable about this whole world of load balancers.
Good. I'm glad.
We've still got more to explore though, right?
We do.
So stay tuned. We'll be back soon to continue our exploration of load balancers.
Sounds good.